So we'll find mass per unit volume of the sphere. Okay, initially in the spherical shell, we had found out mass per unit surface area, right? Mass per unit area. But here in solid sphere, we are going to find mass per unit volume. We'll take this. So volume of the sphere is 4 by 3 pi r cube. So it's m upon 4 by 3 pi r cube. Okay. Now we'll consider this elementary portion of the sphere. And mass of this elementary portion is small dm. Okay, this is the mass of this elementary portion, and we can write this as m upon 4 by 3 pi r cube. This is mass per unit volume. Multiply by volume of the elementary portion. The elementary portion is the disk. Because if you take a thin slice out of the solid sphere, then you'll get a disk. Okay, so we can easily find area of the disk, and by multiplying thickness with the area of the disk, we'll get the volume of the disk, right? So if we want to find mass of the elementary portion, and we assume that we always assume in these derivations that mass is uniformly distributed. So whether we are taking mass per unit length or area or volume, we are assuming that we get the same mass. Okay, and therefore we always find mass per unit length or volume or area. That depends upon the thing we are taking. If we have a uniform rod of negligible thickness, then we take mass per unit length. For ring, we take mass per unit length. For disc, we take mass per unit area. For spherical shell, we take mass per unit area. But now we have solid sphere, so we'll take mass per unit volume. And when you take out the thin slice of this solid sphere, then you'll get a disc. So we can easily find volume of the disc. ठीक है, कैसे करोगे? उसके एरिया को उसकी थिकनेस से मल्टीप्लाई करके you can get the volume of the disc. See, now what is the area of the disc? It's pi small r square. No, and small r square can be written as capital R square minus x square. है ना? We can apply Pythagoras theorem in triangle, right angle triangle AOC, and we know radius of the disc is small r. Okay, so small r square is capital R square minus x square. Okay, so this is the area of the disc, and on multiplying thickness with the area, we get volume of the disc. And when volume of the disc is multiplied with mass per unit volume, then we get mass of the disc that we had taken out. Okay. Now, because of this small mass, we'll find moment of inertia first. See, we are going to find moment of inertia about the diameter of the sphere. And this axis, the diameter of the solid sphere, actually passes through the center of the disc. No? Is it passing through the center of the disc? Is this the line, the same line which we had taken while solving the problem of disc, where we take the moment of inertia about an axis which passes through the center and perpendicular to the plane of the disc? So this is the same line, right? M upon 4 by 3 pi r cube. This is the first thing that we had done, right? And after this, we have considered a small portion, or we can say that we had taken out a thin slice from this sphere. It's like जैसे आपके पास एक बॉल है, उसमें से आप बीच में से एक स्लाइस निकालो. इमेजिन करो कि आपके पास एक रबर बॉल है और उसको आपने बीच में से कट कर दिया, और उसमें से एक छोटी सी स्लाइस को ऐसे you have just moved a thin slice from it. Then what will you get in your hands? That thin slice looks like a disc. No? अनुष्का, अमेहा, हाँ जी बताओ मैंने क्या बोला है. स्लाइस ये कैसे निकाली है हमने? Who is going to explain? अनुष्का, yes?
बॉल को मैं कट कर दिया बीच में से थोड़ा सा पार्ट, तो वो डिस्क बनेगा, क्योंकि वो सॉलिड स्क्वायर है तो उसके अंदर भी कुछ ना कुछ तो है ही.
हाँ बिल्कुल. तो वो एक डिस्क निकलेगी बाहर, और उस डिस्क का रेडियस क्या है अमेहा? व्हाट इज द रेडियस ऑफ द स्मॉल डिस्क दैट वी हैव टेकन आउट? It's small r. Small r. Okay, if small r is the radius of the disc that we had taken out, then what is the area of the disc, Vinamr? You muted. Area of the disk is pi r square. And what if we want to find the volume? Then we multiply the width with the area, right? And Anushka, what is the width of the disk?
dx.
Dx is the width, pi r square is the area. So we can write pi r square dx as the volume of the disk. So if we multiply mass per unit volume with the volume of the disk, then we get the mass of the disk. Sorry, mass of yes, mass of the disk, right? Okay, now this small r square can be written in terms of capital R and small x. See, small x is the distance from the center. ठीक है, मतलब जो सॉलिड स्फेयर है सेंटर से कितनी दूर आपने डिस्क को निकाला, रिमूव किया, वो जो डिस्टेंस है वो स्मॉल एक्स है. अमेहा, हाउ डू वी रिलेट इन अ ट्रायंगल इफ वी हैव right angle triangle and we have hypotenuse, perpendicular and base? Here we have capital R, small r and x. Pythagoras theorem. And here we can write small r square in terms of
R and
x. Capital R and x.
capital R square is equals to small r square plus x square.
Yes, capital R square is equal to small r square plus x square. So in place of small r square, look at the moment of cursor. Now we have written this. ठीक है? Now on solving, pi cancel हो गया हमारा. On solving and simplifying, you'll get this. So this is the mass of the disk that we had taken out. And because of this mass, we are going to find moment of inertia about the axis zz dash. Now this axis is the diameter of the, is along the diameter of the solid sphere. Now forget about the sphere, just focus on the disk. Okay, keep your focus on the disk. We have a disk placed like this, and this is the z axis about which we have to find moment of inertia. Now look at this. We have a disk placed like this, and this is the axis about which we are going to find the moment of inertia. So this is the same axis that we had done in the disk, where the axis passes through the center of the disk and perpendicular to the plane of the disk. No? Okay, so we can write di as dm small r square. That's why we written half here. Half dm small r square. समझ आया कि हाफ क्यों लगाया हमने? हाफ समझ आया? बिकॉज डिस्क के केस में अगर कोई डिस्क होती है और ऐसे एक्सिस परपेंडिकुलर होती है, जिसके प्लेन पे परपेंडिकुलर होती है और सेंटर से पास करती है, तो मोमेंट ऑफ इनर्शिया एम आर स्क्वायर बाय 2 होता है ना? एम आर स्क्वायर बाय 2 होता है डिस्क में. मास डीएम है, रेडियस स्मॉल आर है और 2 भी है, तो हाफ डीएम इंटू स्मॉल आर स्क्वायर. ठीक है? Now in place of dm, we will write the same expression that we had, just derived. And okay, and this r square is, for r square we can write this. Look at the cursor again. This small r square is capital R square minus x. Clear? Again, simplify this. On simplifying, you will get this. Di is this 3m by 8 r cube r square minus x square whole square dx. So this is the small moment of inertia because of just one part of the solid sphere. And what if we want to find total moment of inertia of the body then? What should we do? We will integrate this. क्या करेंगे? Integrate करेंगे. ठीक है? On integrating, you will get this. Total moment of inertia because of the solid sphere. Now we'll put the limits from minus r to plus r. As we have discussed in the previous derivation, I told you either you can write minus r to plus r or you can write twice 2 0 to r, है ना? बताया था ना पिछले वाले derivation में. तो यहाँ पे we have taken the limits from minus r to plus r. Put the write this expression and simplify this. See, again we have written this in the same way, 0 to r. So minus r to plus r is written as 0 to r, and we have written 2 outside the integration, and on solving you will get this. It's a square minus b square whole square. Okay, now you can use a simple integration here, and Because you can see that we have dx, na? So this dx will be operated only on the x, only on the expressions which are functions of x, no? So 2r square is taken outside, r raised to the power 4 is taken outside because they're constant. We have used the formula integral x and dx here, xn plus 1 upon n plus 1. ठीक है, ये आता है ना इंटीग्रेशन आपको, x स्क्वायर को इंटीग्रेट करते हैं तो x क्यूब बाय 3 आता है, x raised to the power 4 को when we integrate then we get x raised to the power 5 by 5. Now we'll put the limits. Now अब क्या करेंगे हम, upper limit minus lower limit is 0, upper limit is r, तो इसमें x के place पे we are going to put, and on further simplifying it, ठीक है, you will get this. So it's 2 by 5 mr square. This is the moment of inertia about diameter of solid sphere. So what is the moment of inertia of a solid sphere about its diameter? It's 2 by 5 mr square, right? So about this axis, moment of inertia is 2 by 5 mr square, and this distance is r. Again, we'll apply theorem of parallel axis here. ठीक है? So therefore, moment of inertia about a tangent on a solid sphere is, so about this axis it's 2 by 5 mr square plus mass of the solid sphere and square of the distance between these two axes. So this is 7 by 5 mr. See, we are rotating a solid sphere about its diameter, and we know the moment of inertia about diameter, it's 2 by 5 mr square. So density is given, radius is given. We have to write in terms of density and radius. See, because we know the moment of inertia, it's 2 by 5 mr square. So mass is volume into density. Volume is 4 by 3 pi r cube and density is d. So on solving this, you'll get this, right? So this is the correct option. हमने कुछ नहीं किया, हमने बस मास को वॉल्यूम इनटू डेंसिटी किया, ठीक है? Next question. Two lead spheres have volumes in the ratio 1:n. The ratio of their moment of inertia about their respective diameter is. Volumes are, ratio of volumes are given, is given, it's 1:n. We have to find ratio of their moment of inertia. मतलब I1 is to I2 निकालना है, V1 is to V2 दिया हुआ है. So for this we will write this mass in terms of volume and density first, because both the spheres are of lead, so they have the same density because they are of same material, lead, right? Because both spheres are made up of lead, so they have the same density. But volumes are different. The sizes are different, but because they are of same material, made up of same material, so they have the same density. Ratios of volumes is given. We have to find ratios of moment of inertia. ठीक है? This is the answer. देखो, first we have two lead spheres. We can draw like this. They have different volumes. Volume of this lead sphere is V1 and volume of this lead sphere is V2. So we can write V1 as 4 by 3 pi R1 cube and V2 as 4 by 3 pi R2 cube. When you'll take the ratio 4 by 3 pi cancel हो जाएगा और हमें सिर्फ ये मिलेगा, R1 cube is to R2 cube. Now this ratio is given to us, it is 1:n. So R1 cube is to R2 cube is 1 is to n. So we can write R1 is to R2 as, because ये cube है. So R1 cube by R2 cube is 1 by n. So we can write R1 by R2 as cube root of 1 by n. Or we can write this as 1 by n raised to the power 1 by 3. ठीक है? Now, how do we write moment of inertia for a solid sphere? It's 2 by 5 mr square. This is how we write for a sphere, and this mass can be written as volume into density. So it's 2 by 5, and for mass we can write volume into density 4 by 3 pi r cube into density and small r square. Yes. So we can see that this moment of inertia depends on r cube and r square. It's r raised to the power 5. Because these values are constant, density is constant, pi is constant, these numbers are constant. So we can see that r depends on this and this. R raised to the power 5. Yes? है ना? Now because r depends on r raised to the power 5, so we can write I1 by I2 as R1 raised to the power 5 divided by R2 raised to the power 5. Now R1 cube R2 cube is this. This was the relation that we had written. This is R1 by R2. है ना? We can write like this. And for this R1 by R2 we are going to write n की power 1 by 3 like this. और इसकी power क्या है? 5 को 1 by 3 से multiply करोगे, you will get this.